in this lecture we are going to determine the lambda max of given sample. The given sample is potassium permanganate. So potassium permanganate is an oxidizing agent and its color is purple color. So we are going to determine its lambda max with the help of UV-Visible spectrophotometer. So to determine the lambda max we have to fix what are the solvents we are going to use and what is the wavelength range we are going to measure the absorbance and all. So we all know the potassium permanganate is a colored solution. So to determine the lambda max of colored solution we have to use a radiation in the range of visible wavelength. So that is from 400 to 800 nanometer, and also the cured material has to be a glass because the quartz material will absorb. Okay, so to determine the lambda max of potassium permanganate, we have to use a glass cuvette, and before we begin the method, we have to set the parameters here in the software. That is, the software we are going to use is UV-Vis, and here we can find the spectrum mode because lambda max can be determined only in the spectrum mode. We have to choose this one, and after choosing the spectrum mode, we have to set its parameters. So as you can see, we are going to measure only the absorbance. So here we have to give absorbance in the photometric mode, and then the scan parameter has to be from 800 to 400 nanometer because this is a color solution and it will be having maximum absorbance only in the wavelength range. So we have to give that as a scan parameter, and the speed has to be a minimum one, and the interval can be from 5 nanometers, so which means the scanning will be done in every 5 nanometer from 800 to 400 nanometer, and we have to fix the display range. We can set this from 0 to 1.5 or 1.8 like that. So we will get a detailed spectrum in this mode. Then I'm going to give OK, and after giving OK, the spectrum parameters will be set up to whatever I have entered here. So now you can see the spectrum parameter wavelength has changed from 800 to 400, and the display range has changed from 0 to 1.8. Okay, so now as usual what we are going to do is we should make a blank, and we have to keep blank inside the reference sample holder, and we have to correct the baseline by clicking this baseline button, and the UV-Visible spectrophotometer will scan the blank, that is water, from 800 to 400 nanometer, and any other absorbance that happened within that wavelength region for the water will be nullified. Then after that we are going to keep our sample, and we are going to measure the spectrum, and with the help of peak we can determine the lambda max of our drug sample. Students are here to determine the lambda max of the given sample, and let's see how they are going to do it.
Replace blank.
Daily landscape.
baseline correction done for blank. Now keep a drug sample.
So as you can see, the lambda max of potassium permanganate is 525 nanometer because it has the highest absorbance. So we have determined the lambda max of the potassium permanganate